Good morning, my students. Welcome to my channel Study Hub. Today I will start the Thermodynamics part 3. Some of my students requested me to write in a just bold and big letters. Okay, I'll try. Thank you.
अच्छा हमको सिखा रिया है.
So start the Thermodynamics part 3.
अगर तुम लोग नए हो तो सब्सक्राइब करो, वो जो लाल वाला बटन है उसके साथ स्कैम करो या फिर महफिल जमाओ, मुझे नहीं पता, बस क्लिक हो जाना चाहिए.
अभी मजा आएगा ना भिड़ो.
So Thermodynamics part 3. Today is discussing internal energy. Internal energy. What is internal energy? तुमको समझना internal energy क्या है and change of internal energy. Internal energy को thermodynamics में जो एक्सप्रेस करना है तो क्या U और E. U और E. You can write U or E. And change of internal energy. चेंज ऑफ इंटरनल एनर्जी को बोलेगा डेल्टा यू. दिस इज द चेंज ऑफ इंटरनल एनर्जी. चेंज ऑफ इंटरनल एनर्जी डेल्टा यू. ओके, तो इंटरनल एनर्जी क्या है भाई? इंटरनल एनर्जी डज नॉट मीन इंटरनल एनर्जी मेरा इंटरनल एनर्जी कोई बॉडी का, कोई सब्सटेंस का, कोई सिस्टम का. स्पेशली यहाँ पर क्या गैस है तो कोई सिस्टम का इंटरनल एनर्जी डज नॉट मीन द थर्मल और हीट एनर्जी. और विदिन द बॉडी और द सिस्टम देयर आर सॉलिड हो और लिक्विड हो और गैस हो, टोटल एनर्जी विल बी व्हाट? विल बी द लाइक काइनेटिक एनर्जी. इंटरनल एनर्जी मीन्स काइनेटिक एनर्जी. i.e. इंटरनल एनर्जी मीन्स ये हो सकता है काइनेटिक एनर्जी प्लस ये हो सकता है पोटेंशियल एनर्जी प्लस ये हो सकता है इंटरनल टोटल एनर्जी. सॉरी, ये टोटल एनर्जी ऑफ द बॉडी, टोटल एनर्जी ऑफ द सिस्टम, टोटल एनर्जी ऑफ द बॉडी इज द काइनेटिक एनर्जी, पोटेंशियल एनर्जी, उसका इंटरनल एनर्जी. ओके, काइनेटिक एनर्जी क्या है? जो बॉडी मोशन है, जो बॉडी इन मोशन, दैट इज द बॉडी मोशन ऑफ द बॉडी. इन केस ऑफ काइनेटिक एनर्जी उसमें है. पोटेंशियल एनर्जी हो सकता है व्हेन द बॉडी, दैट इज द ग्रेविटेशनल पोटेंशियल एनर्जी हो सकता है, इलेक्ट्रिकल पोटेंशियल एनर्जी हो सकता है. इन केस ऑफ एनी बॉडी, एनी सिस्टम मेड अप ऑफ एटम्स, मॉलिक्यूल्स एटम्स है, मॉलिक्यूल्स है. तो मॉलिक्यूल्स जो है तो मॉलिक्यूल्स वो इंटरनल एनर्जी क्या है? तो मॉलिक्यूल का एनर्जी है. एटम inside the atom, inside the molecule there are atoms and there is the molecular energy. In case of solid, in case of liquid, in case of gas, what is the solid? In case of solid, the molecules are rest, fixed. In case of solid, liquid, this is the in case of liquid, what the molecules through migrate. But in case of gas, there is random movement, which is the Brownian motions. In case of liquid, there is a Brownian motion is taking place always. Okay, so this is the internal energy. It depends upon the molecular energy. The random motion in case of gas, Brownian motions. In case of gas, what do you see? Internal energy, the potential energy of the molecules. Vibrating molecules क्या होता है? Vibrate कर रहा है, to and fro motion हो रहा है, to and fro spin कर रहा है. ये vibrating energy दिया, vibrating kinetic energy, rotational kinetic energy, spin kinetic energy. All type of energy are within the system or within the objects. So total energy होता है क्या? Total energy, that is internal energy of a system does not mean only the thermal energy inside it. It contains all, the summation of all energy. This is the summation of all energies. Summations of all energies is the internal energy. Internal energy. But a total internal energy of a system cannot be determined easily. Internal energy, suppose that within a molecule, atom or photon or electron, neutron, all are spinning in the cells, in their orbit. So in that case, the energy cannot be determined easily. So many processes are there. So how you will determine the internal energy of a system? In case of थोड़ा molecule जो है, the system के internal energy easily calculated नहीं, cannot be done. Okay, so in this case, what is system? But internal energy of system can be changed. Internal energy of system can be changed. How? By applying the heat. Heat apply करो, or heat उसका absorb करो, or work done on the systems, on the body, work done by the body. I will discuss just little bit. Okay, so total energy, what is internal energy? बहुत इंपॉर्टेंट है, अंदर का शक्ति है, अंदर का शक्ति है उसका. What is internal energy? Yes, internal energy actually it is the total energy contained by a thermodynamic system. Internal energy is the total energy contained by a thermodynamic system known as internal energy. And this internal energy may be in the form of magnetic, mechanical energy, potential energy, electrical energy, spin energy. So any form of energy. Any form of energy. And internal energy is an extensive property. Is the extensive property. Clear? And internal energy depends on what? अंदर का शक्ति depends upon the quantity of matter. Depends what? एक number quantity of matter. Quantity of matter. Quantity of matter. Quantity of matter or quantity of the system. Whatever you do, matter or system. Body. उसका quantity में depend कर रहा है. That is, what is this? It is the stress functions. It is not the part functions. It depends upon the quantity. That's why I have told it is a part function. No, it is the what? State functions. State. It is that depend upon the quantity of the matter. And on the nature of the system also. It depends on the nature of system. Nature में जो है तो in nature and quantity of the system. And it is a state function. It also depends upon the temperature. If temperature increase, the internal energy increase. Temperature decrease is also depend upon temperature. Temperature increase, internal energy increase. That is the internal energy increase. A decrease, so internal energy decrease. So this is the some criteria through which internal energy depends. Clear? So see out here. So what is so we can change the internal energy. We cannot calculate, but we can change. How? By applying the heat. I also told earlier, a system जो है, a system है, इसके अंदर तो गैस ही है, गैस मोलिक्यूल है. Okay, we can change by this piston है, a system है, a surroundings है. If heat is given, so इसके अंदर heat क्या होगा? It absorb करेगा, एनर्जी बढ़ेगा, हमको हीट देगा तो हमको एनर्जी बढ़ेगा, तो दैट मीन्स इसको सिस्टम का अंदर एनर्जी, इंटरनल एनर्जी विल इंक्रीज. ओके, इट विल इंक्रीज. दैट इज डेल्टा चेंज ऑफ एनर्जी हो सकता है. एनर्जी पहले उसका एनर्जी कितना था हमको मालूम नहीं है. What was the energy, internal energy, but I don't know. But if I apply, suppose 50 joule or 50 calorie joule of heat I have applied. So इसका जो इंटरनल एनर्जी था उससे थोड़ा ज्यादा हुआ. कितना हुआ? इनिशियल एनर्जी, इनिशियल से 50 ज्यादा होगा. दैट इज द फाइनल. इसका वॉल्यूम फाइनल हो गया. बाय एनर्जी फाइनल हो गया. वॉल्यूम increase, the volume will increase, the piston also increase. It has done, it will do some work. Okay, so in that case, the final, the V initial and the V final, that is U initial plus 50 होगा. जो इनिशियल था उससे 50 ज्यादा होगा. If it worked 50 joule, the system itself does the work. That means it releases energy. In that case, it will be minus. Okay, so work done minus. So I am coming back. So internal energy जो है, I will increase. We can increase the energy of the system. We can increase or decrease, or we can increase the internal heat, internal volume, decrease also volume by applying heat and what? By doing work. So remember one thing, I am coming the heat and work. The total internal energy in case of ideal gas लिए internal energy in case of isothermal process. In the isothermal condition, isothermic, then its temperature is remain same. In that case, for ideal gas, that is delta T equals to 0. Delta T 0 means उसका change of internal energy will be 0. Remind it. Okay. That means उसका volume, suppose A से B, इसका energy, internal energy UA, इसका internal energy UB. After applying this, so in this case UB, the final UB minus UA. Final value UB minus UA. If UA, this is greater than, UA is greater than UB, that means system does the work, that is released energy. In that case, it will be minus. If it is greater than, okay, UA greater than UB, that means delta V will be what? Negative. Why? It's released energy. If UA less than UB, that means what that means? It absorbs energy. Energy is absorbed. In that case, delta U. In that case, delta U will be positive. In that case, delta U will be negative. That is work done by the system. Work done on the systems. Work done by the systems. Work done on the systems. Okay. And this heat, all these things can be calculated by Bohm calorimeter. Okay.
इसीलिए समझ रहे हो ना.
How to see the internal energy? So remember one thing, that in case of gas, when the gas is rest, then in case of rest, the internal energy of the ideal gas will be the kinetic total energy equals to internal energy. That is the kinetic energy of the gas. Okay. The total energy is the internal energy equals to kinetic energy of the gas. Remember it. Okay. And number of, because there is no force of attraction. Kinetic theory of gases you have learned. There is, in case of rest, in case of ideal gas, there is no force of attraction. So in this case, internal total energy will be the internal energy. Okay. That is the main thing. Now, you know, if a system, then in the system, in this system, the piston out there, in this system, if you want to increase if you want to increase or if you want to decrease, that is the internal energy. If you want to change, the energy change of the internal energy can be changed, may be changed. How? What is the how we can change the internal energy? I have told. Remember it? No. Yes, correct. Yes, it is can be changed by the when matter enters or matter leaves the system. Okay, or heat passes or heat, that is matter enters or matter leaves. Okay, or heat, that is the heat. Heat passes in or out. It can pass. Okay, it can leave from the system. It enter in the system. It pass from the system. Okay, what work is done? Work done on the system. Work done by the system. I am doing. Okay, I am doing something. हम पे काम कर रहे हैं कोई. So in that case, the internal energy may be changed. But remember it, total internal energy of the system is constant. That means, and total energy, internal energy of the system is constant. Clear? So, what we learned out here, if the heat and work, okay, heat and work, heat change and work change, delta H, delta W, heat and work denote this. So, remember things when, if energy is released by the system, heat energy is released is released by the system, that means delta Q, change of internal energy, what? Positive or negative? Yes, negative. Heat is released by the system. That is, what out there? Q less than 0. Q less than or greater than? Less than 0. Yes. That means delta U equals to negative and Q less than 0. Opposite case, if energy, that is the heat is released by the system. If it absorbed by the system, it is positive. Clear? If energy, in case of energy, in the form of heat is from the energy, if energy is absorbed by the system, heat energy is absorbed by the system. What? That is Q greater than 0. Heat energy is absorbed by the system. Heat energy is absorbed by the system, that is Q greater than 0, and in that case delta U equals to positive. Remind it. This is it. It is released, it is absorbed. When it is released by the system, it is absorbed by the system. This negative, this positive. So any system or surroundings, what is see? This is the system and surroundings. System, this is surroundings. This is system. Clear? A system and surroundings अंदर एनर्जी इन एंड आउट होगा, किसका मतलब होगा? एनर्जी एब्जॉर्ब होगा, एनर्जी रिलीज करेगा, कैसे होगा? ऑटोमेटिक नहीं होगा. कैसे? एनर्जी एब्जॉर्ब होगा और रिलीज होगा by the means of two things, and heat and energy. This is the main thing, heat and energy. That is work. That is work. Heat and work. ये दोनों का इम्पोर्टेंट, इससे माध्यम से सिस्टम का एनर्जी क्या होगा? इन होगा और आउट होगा. The initial internal energy is in system, is stored, internal energy stored in the system. Internal energy stored in the system. But heat and work, these two energy do not store. Heat and work, they are dynamic. They do not store. Remind it. Okay? Next. Clear, bachcho? So heat and energy, heat and work, very important thing, and this is the main thing I have discussed earlier. This is the step function or path function. Yes. Heat and work is the path function that does not depend upon the state. They are the path function. Heat and work, path function. Okay? Whereas internal energy is the state function. Clear? So heat, we can We can also write heat. In case of the air, we can denote it Q. Okay, I write the H, but we denote by Q. Only one student told me. Yes, take it, right. Heat Q and what is W. Okay, so heat, you can symbolize the heat by writing Q. The heat and Q, they are not state function. They are, but whereas internal energy U, they are heat and work. W, this is the path function. Whereas delta U, that is in change of internal energy, state function. Okay, remind it, state function. Whereas in the beginning, in the beginning I have told, and they are path function. They depend how the system, that is heat and work, the system, how the work, how the system reach in the final position, in that position. Suppose there is ice. Okay, ice. Okay, and this ice change into water. 0 डिग्री सेंटीग्रेड में वाटर हो जाएगा. इससे भी हो जाएगा. कैसे? By applying heat. Or by applying work. That means I am giving pressure. The frictional force is there. Pressure is there. So ice made into water. 0 degree centigrade. So this depends upon, does not depends upon the state. This depends upon the path. In which path? Okay, the work done. That is a change of heat. Depends on path, but not on state. And it can be unit, I do not, it is the joule or arc or calorie. And 1 joule 10 to the power 7 arc, all and it is the calorie. Okay. So change in internal energy when work is done. Now we'll discuss change of internal energy when work is done on the system or by the system. Change in internal energy, that is delta U, when work done by the system or on the system. Okay? Work done by the system, on the system. Suppose there is a system. Okay? The system contains some gas. Okay? The system and surroundings. Okay? Then you must remember this is in case of adiabatic. This is adiabatic system. What is adiabatic system? I have told earlier. Adiabatic system means no heat is transfer. No heat transfer is, but work done. Adiabatic system, no heat. Heat of transfer, that is Q, will not be possible. But what can be done? So, work done by the system on the system. And work transfer. Yes, that is work transfer. Work can transfer out here in this adiabatic system. Okay? The internal energy can be changed by doing some work on the system. By how? You can do by work directly, how? Or indirectly? By mechanical work. By mechanical work. M-E-C-H, mechanical work. Or by electrical work. Electrical work. How? How you can change by mechanical work? Nothing is just example. Let's example. This is the system. What there? You have insert a churner. There is water. The churning the water. Churn it. Mechanical work churning. Heat can be increased. Initial temperature, whatever you can measure. After that, you churning the water. You can increase the temperature, heat. Okay? And by electrical work, insert an immersion rod, and you can increase the heat, temperature of the water or the system. Okay, that is the by applying electrical work, by applying mechanical work, you can change the change in internal energy. That is delta work. Delta U. So what is the change in delta out here? Change in internal energy. Okay, that is this work is known as the adiabatic work. This adiabatic work what? W adiabatic, yeah, W adiabatic work. क्यों होगा यहाँ पर पॉजिटिव होगा कि नेगेटिव होगा? When W is positive, when W greater than, yeah, W greater than 0, it will positive. Then when work done on the system, it will be positive. That is out here work greater than 0. And at W adiabatic in system equals to negative when work done by the system or done by the systems. In that case, W less than 0. Clear? The work done on the system, work done by the system. In case of positive and negative, this sign is very important. Next. Okay. So, I am coming next. इससे बात आएगा जो तो स्पेसिफिक प्रॉब्लम, न्यूमेरिकल प्रॉब्लम आएगा. सब इंतजार कर रहे हैं, आएगा. थोड़ा समझो, वेरी इंपॉर्टेंट है. कब पॉजिटिव होगा, कब नेगेटिव होगा, उसका इक्वेशन क्या होगा, इंटरनल एनर्जी का इक्वेशन क्या होगा. ओके, इन इंटरनल एनर्जी बाय इट. ओके, सो सपोज दिस इज द कंटेनर, दैट इज सम थिंग or somebody or matter out there, yes, and this container again placed within a reservoir, another container, and this is volume is constant, and here what we see that this is thermal conducting wall, that is heat can pass out there. So initial temperature iska T1, iska temperature T2. If temperature in or out, this is the thermally conducting wall. Okay, so heat can pass out there. That means when Q equals to negative, when Q equals to positive, you must remember what? This is the, suppose this is the system, this is the surroundings. In here, this is system, this is surroundings. That means when it is transferred from system to surroundings, or it is transferred from surrounding to system. So it is transferred from system to surroundings. That is system to surroundings. That is minus. In that case, Q goes to minus. And when it's system to surroundings, that is release हो रहा है, energy कम रहा है. And when it is transferred from surrounding to system, in that case, that is positive. Clear? That is positive. The changing, that is Q is positive and Q is negative. Negative and positive. Surrounding में system से और system से surrounding में heat transfer हो रहा है. Okay? What is out here? So the total heat or energy, heat or work, what I am applying the system, that it is done by the system, done on the system, work done by the system, work done on the system, system release the heat, system absorb the heat. This condition is happening. So you have to finally even it is the system out there. Clear? System out there. If work done on the system, work done on the system. Clear? That is system W greater than 0 out here. Again heat added. Heat is added. Heat added on the system. In that case, it will be positive. Clear? And here, heat is released by the system. It is Q less than 0. It is Q greater than 0. Clear? Again, and work done by the system. W less than 0. It is negative. This is system. So work added to the system, heat added to the system, heat released by the system, work done by the system. In that case, it is negative, delta Q, it is positive. Remind it. Okay? This is sign convention is very important. Okay? What work done, in what I know, the work W equals to displacement M into G into H, half into M into square. And in this case for gas, I will do the minus Px delta V. work done minus P external dV. I will explain in the next class. Very important. From the next class it will be very important, and some sums also done. Today I am doing only one sum for your reference and for your better convenience. Next an example. Suppose a system is there. In the system, 400 calorie heat is applied. That is work done. That is heat is given to the system, and by taking the heat, the system works. System work done by the system. Suppose he has done 250 joule or calorie work done by the system. In that case, what is the internal energy change? In this case, in delta U equals to work done plus this. This is the work done. So out here, heat is absorbed by the system. So it will be plus, that is 400, and work done by the system, that is it will be negative. So this minus this. This is the internal change of internal energy equals to this minus this. Okay. Okay. This is the calorie. If the work done by the system, that's why it is negative. Work energy is given to the system, that is positive. If work done, it is given, and work done on the system, so in that case it will be positive. So what we get out here, delta U equals to plus minus W plus minus Q. Why plus minus? Why plus minus? When both are absorbed and it is done on the system, W plus Q, this work done by the system, it is released by the system, दोनों minus होगा. So this is the equation of the total internal change of internal energy. Remind it. Clear? So goodbye. Thank you. I will give the numerical problems in the next. So please subscribe and share my channels to your favorite friends. Thank you and help me. I will be happy. Goodbye.
खत्म. बाय बाय, टाटा, गुड बाय, गया.